Okay, this is another video on components of an experiment, fairly long free response problem that was given, and actually fairly difficult one. So this came off of AP Statistics Test year 2006, Form B, and is question number 5. When a tractor pulls a plow through an agricultural field, the energy needed to pull that plow is called the draft. By the way, first time I read this problem, I learned a new word. And so basically the energy needed to pull the plow is called the draft. The draft is affected by environmental conditions such as soil type, terrain, and moisture. And basically they're saying, hey, we know you don't know what this is, so we are providing you information, which is why it's really important to read the entire problem. Okay. A study was conducted to determine whether a newly developed hitch would be able to reduce the draft compared to the standard hitch. So here's what we're doing. We're comparing a newly developed hitch to a standard hitch. And then they tell us what a hitch is. A hitch is used to connect a plow to the tractor. 2 large plots of land were used in the study. It was randomly determined which plot was to be plowed using the standard hitch. Okay, so we have random assignment, that's good. And use the standard hitch. As the tractor plowed that plot, a measurement device on the tractor automatically recorded the draft at 25 selected points in the plot. So real quickly, let's think about this real quickly, because we're going to make a mistake later if we don't. We have plot 1 and we have plot 2. So we basically have 2 plots of land. So this is going to get 1 hitch, and this will get the other hitch. All right, and we're going to randomly assign the hitch to one of the plots. So notice only 1 plot for 1 hitch and 1 plot for the other hitch. That's going to be important. After the plot was plowed, the hitch was changed from the standard one to the new one, a process that takes a substantial amount of time. I think they're just whining and wasting time here. They didn't need to say that. Then the second plot was plowed using the new hitch. So basically, here's what happened. Plot 1 got the standard hitch, and plot 2 got the new hitch. Okay. After the plot was plowed, the hitch was changed, and we took 25 measurements of draft recorded with the at randomly selected points in this plot. What were the response variable in this study? Identify the treatments. What were the experimental units? Well, the response variable in this case is what were you measuring? And well, what we were measuring was the draft. All right. So the response variable is the draft or energy needed to pull the plow. And we could have just said the response variable is the draft, and we would have been fine. Then it asked, what are the treatments? Well, the treatments are the type of hitch. All right. So we had 2 treatments, the new hitch and the standard hitch. The experimental units are the 2 different fields, all right, or the 2 plots of land, because that's what we experimented on, right? Sometimes we refer to, instead of experimental units, we'll say subjects, but the subjects were the 2 plots of lands. We usually use subjects when we're talking about humans, or animals. The experimental units are the 2 different fields. Part B, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly in the study? Well, they didn't tell us how they randomized. I'm hoping they put it in a hat and mixed or used a random number generator, but they did say it was randomly assigned. Randomization was properly applied because the 2 hitches, the treatments, were randomly assigned. They didn't tell us how they did it, but they said that they did randomly assign it. So we're going to say they did it properly. Once again, we can't say random assignment was provided. We have to put it in context. The context is 2 hitches were randomly assigned to the fields. Context, please don't forget context. Given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was replication used properly in the study? Justify your answer. Well, I'm going to go back to our diagram that I sketched out real quickly. How many plots was the standard hitch given to? And the answer is 1. To be replication, we have to have more than 1. Here, the new hitch was only assigned to 1 plot. We did not have more than 1 plot, so we don't have replication. And the problem is the plots could be confounding variables. There could be something different between the 2 plots of land. This farm and this farm may have vastly different soils. All right, we'll talk about that in part D in just a moment. So replication was not properly employed. Each treatment was only applied to 1 experimental unit. For replication to have occurred, the treatment, the hitches, so now I put it in context, would need to be used on multiple experimental units or plots of land. Again, I had to include the plots of lands and the hitches to put it in context. You must put your answer in context. Plots of land is a confounding variable in this experiment. Explain why. The plot of land is a confounding variable in this experiment because different soil conditions between plots, such as rockiness, soil compaction, root growth, and wetness, will impact the draft. You only needed to come up with 1 of those. You did not have to come with all of those. Thus, we are not able to determine whether the hitch or the plot is creating differences in the draft. The plot is confounded with the hitch. We don't know what's causing the difference. Remember, we have 2 different plots of land here. All right, this could be on the north side and be extremely rocky and very difficult to pull. This could be further on the south side of San Antonio, in which case we have more clay soil that would be easier to pull through than a rocky soil on the north side. Okay, all right. And you're like, well, you have to know something. Well, if you don't, kind of make something up. Think about it and make your best application. All right, and this concludes this video.